Good afternoon, ladies and gentlemen. Thank you for joining me here in the review for the semester 2 Math 3 final. In this video, we're going to talk about a little bit of statistics, right? We're going to be talking about the empirical rule. I might make a separate video for the C-score. We'll see right now in a bit. But yeah, uh, here, join me. Let's talk about this empirical rule. And you know what? I should label it that and not just call it stats because we're talking about a very specific topic. Okay, so you should have your formula sheet out and somewhere to do some practice problems. Right now, we're going to first talk about the formula, the concept, right, behind the empirical rule. So the empirical rule could also be seen as normal distribution. And we generally have this bell curve of a graph. Let's see how good I can do this graph. All right. That's my best attempt at doing a normal distribution graph, the bell curve. Now, the bell curve is going to be this graph that is going to help us organize our data. Right in the middle of it, we're going to have the average. Okay? And in a problem like this, we're going to be hopefully given the average, the standard deviation, and that kind of information is going to be very valuable to building the graph. Right here, when you start with the mean, you're going to come over to the right and you're going to draw another line. This line is going to be given by the average plus 1 standard deviation. At the same time, if you go to the left side of the graph, we have the average minus 1 standard deviation. This chunk of data, according to the empirical rule, is going to already contain 68% of the data, 34% in each section. Okay. Now, if we go and move over to the next section, which is the standard or the mean plus 2 standard deviations, that is going to contain 13.5% of the data. In addition, right, to the 68 that we have already captured. So let's go ahead and do that on the other side. The mean minus 2 standard deviations. It will also contain 13.5% of the data. Now let's keep track of how much data we've already collected, right? From the first standard deviation away from the mean, we've already collected 68% of the data. So now if we extend that all the way to 2 standard deviations, well, now we have 68 plus 27, which brings us to 95% of the data. So just by going 2 standard deviations away from the mean, almost every data point is going to be captured within that. So what happens if we go further? Okay, now we go 3 standard deviations away from the mean in both directions, minus 3 standard deviations. Well, each different category, each different section is going to have 2.35% of the data. So how much is that in totality? Going from the 3 standard deviations to the left all the way to 3 standard deviations on the right. Well, we are adding 4.7 to the 95% that we already have. So that gives us 99.7% of the data. And then the remaining 0.3 is going to be, it could be 4 standard deviations away, it could be 5, really depends on the outliers, right? So we're just going to go ahead and label it 0.15% here, 0.15%. The data is now too small for us to chunk it using standard deviations. But this is the empirical rule. So now that you have your notes, your concept, let's see how it works with some examples. I have this example here ready for you. Here you go. Copy it down. You don't have to copy the actual question, right? Just be efficient and take what you need. But it says 500 juniors at Central High School took the SAT last year. The test scores were normally distributed. The mean is 24. The standard deviation is 4. We're going to label the mean and 3 standard deviations from the mean. So if the mean is 24, that's going to go right in the middle. And because the standard deviation is 4, just take the 24 and add 4 to it, giving us 28. Add 4 more, 32. And they say they want us to label 3 standard deviations. So we're going to go one more to the right, and that's going to be 36. Now, as we move to the left, we're going to subtract the standard deviation. So 20, 16, and 12. And it doesn't say for us to label the percentages, but we are, right? We know this is 34%, 34, 13.5, 2.35, and then 0.15%. 13.5, 2.35%, 0.15%. Okay, so let's see the questions. What percentage of scores are between 20 and 80? Okay, well, here's 20 and here's 80. And if you look inside those green lines, we have a total of 68%. Right? So you're going to say 34 plus 34 equals 68% of scores are between 20 and 28. That's it. Make sure that you write a sentence with this because we do have to make sense of the data. What percentage of scores are between 16 and 32? All right, so if you guys identify 16, we're here. 32 goes all the way to this guy. So we're talking about all these percentages. Okay. If you have your empirical rule, your concept sheet, we already know that that's going to be 90. We said 95% of the data. Okay. So we can just say here 95% of scores are between 16 and 32. And again, that's because I added the 13.5, 34, 34, 13.5 to go between 16 and 32. Okay. What percentage of scores are between 16 and 28? So as you can see right now, these kind of problems are all about adding percentages, right? 16 and 28 are right here. I'm going to add 13.5, 34, 34. Okay. So now, for the sake of the video, I'm going to skip my sentence and I'm just going to show you the answer. But we have 34 plus 34 plus 13.5. That would be 68, 71, 81. 81.5% of scores are between 16 and 28. What percentage of scores are less than 12? So if you're talking about less than 12, first you have to identify the 12, and then you have to talk about all the scores that are less than that. So to the left of it, and we're going to say 0.15%. Make sure you put the 0.15, right? Don't just put 15%. That would be wrong. Are less than a score of 12. Finish the sentence. What percentage of scores is greater than 24? Okay, 24 is like dead in the center, right? Right in the middle. That's the average. So because this is normal distribution, the sides are symmetrical. Meaning the first half is equal to the other half. Right? These two pieces are exactly the same. So you don't even have to add up the scores. You should already kind of intuitively identify that it's 50%, half, right? Half of 100. 50% of scores are greater than a score of 24. Okay. Approximately how many juniors scored between a 24 and a 28? Okay, so now we're talking about actual people, right? Not just the percentage. We want hard numbers. How many students scored between a 24 and a 28? Well, first of all, we have to know that it's 34% of the students, right? Okay. So let me do my work over here. F 24%, and there are 500. There's 500 students testing. Okay. So first of all, you need to convert a percentage into a decimal. Pretty simple, a pretty simple conversion. All you gotta do is take the percentage you want to convert. You know what? Here, let me give you a little formula. The percentage divided by 100. So in this case, we have 34% that we want to convert. We divide it by 100%, technically. Think about the percentage canceling, and you get 0.34. Now, how many students scored between a 24 and a 28? Well, to figure out a quantity, take the percentage in decimal form. So I'll say the decimal, and multiply that by the total number of students or data points. I'll say students because that's what we're talking about in this problem. So in this case, we're talking about multiplying 0.34 times 500. Let's go ahead and put both those in parentheses. 0.34 times 500, that's going to give me, oops, did that. It's going to give me 170 students. So 170 students scored between 24 and 28. Approximately how many juniors scored between a 20 and a 28? Okay, luckily for that, we already have the percentage, right? In question A, we figured out that it was 68% of students. So let's do our conversions. Blue right here, G. 68% of students scored between a 20 and a 28. And if I divide that by 100, that's going to give me 0.68. Now, how many students? We're going to take our 0.68, multiply that by 500, 0.68 times 500, and that gives me 340. So 340 students scored between a 20 and a 28. Finish the sentence. Let's do one more. Let's see. Approximately how many juniors scored between a 24 and a 32? Question H seems very similar to question G, and so does I. Let's see J. Approximately how many juniors scored higher than 32? Why don't we tackle that one? Here's 32. So how many scored higher than that? Well, it's these percentages. Okay, let's figure that out. J. We have 2.35% plus 0.15% That's going to equal 2.5%. Now, what is that decimal conversion? 2.5% divided by 100 is going to give me 0.025. And now that I have my decimal, the percentage as a decimal, I'm going to take my 0.025, multiply it by 500. 0.025 times 500. That's going to be approximately 12.5. And because we're talking about students, we're going to have to round. So approximately 13 students scored higher than 32. And that right there, ladies and gentlemen, is how you can use the empirical rule to calculate percentages or to calculate quantities. All right. I'm going to stop the video right here, and I'll see you guys next time for Z-score. Thank you.